In this next video, I would like you to learn about the power tools we have in the Salter Lab. Let's switch here to the desk cam. The first device I would like to show you is this impact driver. There's a battery, lithium-ion battery. It will need to be attached. You can push the button in the back and it shows you how much it's charged, 3/4. Alright. So it looks a little strange. It has a light here. You can change the direction by pushing this button. Right. And push the other button. Push the other way. Okay. Also the speed you can adjust by pushing just a little bit and all the way. Okay. So with this device you want to tighten screws. For example, you can put in this guy, extender, and the Phillips bit. Okay, now you got a motorized screwdriver. This will work, of course, in this fashion. Right. When you turn this, you need to make sure you put sufficient force towards the screw. I will not want to put this into the desk, that would be dumb. But if you're not putting sufficient force, what will happen here? It will slide along the indentation. This will break the tip on your screwdriver as well as your screw, and then you cannot unscrew it anymore. Right? So what is the difference between this impact driver and this drill? Right, again, we want to charge the drill. We'll put some battery into the drill. We can check in the back. It's full power. What's the difference between those two things, right? Because we could just attach our drill here, but it's really not recommended. First, you might break this clamping mechanism, and this guy is specifically made to not apply a constant torque. Here, on the drill, you can adjust the torque by the number, and here there's nothing to adjust. This actually has a torque that spikes. So each time it goes around, there's little torque, a lot of torque, little torque, a lot of torque. It's like you use a hammer. This will significantly reduce the torque on your wrist, and you can have much higher forces to tighten screws with this device. So to release it, you need to pull this forward and it comes out. Now on some occasions you actually also want to tighten a bolt like this one. So you can insert this device, adapter, grab a socket from a kit and turn and tighten your nuts and bolts. Okay? So this is your impact driver. And I showed you the impact driver, the adapter for sockets. I showed you how to tighten or drive wood screws into wood and assemble your furniture. This is just an extension. Smaller one. Let's take a look at the drill bit. That's the drill. That's your second piece of equipment I want to show you. It's the same thing. There's a light here. You push a tiny bit, it moves one direction. Push more, it goes faster. You push on this button, the other side, it will go the other way around. Okay? Now on the top in this case here, it has a 2 and a 1. Let's see what happens on 1. It turns really slow. If you go on 2, much faster. So this is a gear. It has a few more settings. Okay. This setting here is for drilling. This setting is for screwing screws if you want to screw a wood screw. And this is a hammer. We will talk about this shortly. When you apply this to screws, you have different settings here. Setting number 1. Let's see. And you can see that this gets smaller and smaller, and you can basically hold the drills or the bits. If you have this on the smallest number, see what happens when I hold it. Right? It limits the amount of torque you can put on. You go a little higher. I need to hold much stronger. Let's go to the largest number, 21. Right. Okay. If we go to drilling, I think this will be disengaged. And I can just hold this as hard as the motor can drive this device. Let's see if we move this to the hammer symbol, what actually happens in here. There is a device that moves this forth and back. So if you use a drill, it would not be this kind of drill. This is a wood drill or a metal drill. There are special drills to drill in concrete. You would use a drill like this, and it would continuously hammer against your concrete and drive it forward into the concrete. Okay, so I just showed you how to switch the tool to a drill. Okay, and we want to drill by hand into a part, and of course I don't want to drill in the table. Last semester I think we had about 2 or 3 holes in the table. Maybe this semester we will have 0. Let's see. So I got some parts to drill. Right, you have one piece you put underneath that you can easily drill into and throw away, and you have the part you want to drill. So now you can drill. Be extremely careful when you use this, because if the part is getting stuck on the drill and it starts rotating, and this can hit your belly, it can hit your fingers, it's not a good thing, right? So you go over slowly when you want to drill. So now, when a part is as thin as this one, it probably doesn't matter too much whether you drill sideways or this way. You can still attach the screw or the bolt or whatever you want. But if you want this to be straight, right, you locate the piece where you want to drill into as precisely as you can. This is not 100% accurate. Now you look from the front, make sure that this is perpendicular. Then you move around and look from this side and make it sure it's perpendicular, and then you're ready to drill. And you can actually see that I engaged the hammer, and for this kind of drilling, that's really not what you want. You just want a regular drill. Drill into the part and run it all the way through. Okay? Of course, you need to have some gauging to not get too far through the piece underneath. This is drilling your part here. Be aware that the smaller the hole, the lower the speed. Right? If you have a big drill, it will move much faster. It will cut more when it moves fast. So this drill, in small hole, or the smaller the drill, the faster you need to rotate it in order to get the drill cut, the hole cut. Okay, so the next thing we want to do, we want to look at the drill press. To cut or to drill a hole with drill press has an advantage because you can make sure that the attack here is perpendicular to the part. This is your key to open the chuck. Right? If this is missing, nothing's going to work. So if you take this with you, you really have a problem. Right? Even in one of the boxes or somewhere on your table. Usually this is attached with the key, with a string, or with a wire or chain to the actual machine. So we can open here and close. So let's get one of the drills we just used before. Okay, where did I put it? Okay, let's put the drill into the chuck. Tighten this thing. Okay. Now you can see here, there is a hole in the center. So if we go down, this is not going all the way into the device because we have a very, very shallow piece. So we can loosen table here. Move this higher up. Okay. I will try to make sure it goes into the hole. If you need to drill elsewhere, you need to put a wood piece underneath. Okay, so that's a good place. I tighten the stage or the table. Okay. Now if I move this down, it will go nicely into the wood. We can turn this on. When you turn this machine on, it has a pretty strong motor. No loose clothing, no long hair. Everything needs to be back, and safety glasses need to be on. Okay? That's a decent speed. But this is really powerful, so I do not want to hold this by hand. Okay, let's turn it off again. And for that purpose, we're going to use a clamp. All right? So I tightened it, and it can no longer move. Okay. Of course, you have to move it around first so that it's exactly centered where you need it. And you drill pretty fast, pretty quickly. Okay. That's pretty much it. Now, if you have a really small hole to drill, you need to have this go faster. Or you have a really big drill, you want to get it slower. And for that purpose, I show you how you can adjust the speed. To adjust the speed, you need to open this device. And you can see there is a whole bunch of pulleys in here, with this being big and this being small. Right? This rotates, this goes slower, and even slower over here. Small, bigger, biggest. So fast, a little slower, much slower. So you can adjust the belts. These are trapezoidal shaped belts in here that you can move forth and back. So before you can move it, you will need to untighten the motor. Right, so now we can move the motor further in. And you can see that this has become loose, and we can start switching these belts around until we get the speed we want. There is a nice table up here for the RPMs. High RPM, small drill. Low RPM, big drill. Okay? And of course, once you're done, you will need to tighten the motor again. Right, let me do this right now. I just move this by hand as far back as I can. And I tighten these screws on the front and on the back. There's one in the front and on the other side. And now my belt is tight again. I can close this up, and I'm good. Of course, if you have a funny man that will turn on the motor when you work on it, that would be a bad idea. So with this machine, you have significantly more power than with the hand drill. So you need to make sure all the safety precautions are met, which means no loose clothing, as I already mentioned, no long hair, and of course, nothing that can be pulled into the machine or being wound around, and you will not operate anything on the belts or adjusting these belts when you never have 100% control over the on and off switch. The next item I would like to show you is a vise, and how to file on a vise. The vise is just nothing else than a tool that grips your workpiece, and then you can start working on your workpiece. One of the problems on a vise is that it has pretty strong indentations, and if you don't want to create indentations on your material, you need to put these protectors on it. Right, it's just a bunch of rubber. If you squeeze screws with this, you will break it. Right, but a piece like this wood piece would be ideal. You grab it as close to the center as possible. Don't have it stick out too much, and then you can file. Right? When you file, these teeth only cut when you push forward. So to pull down when you pull backwards is not a good idea. You pull down when you move forward. If you want the surface to be flat, you try not to wiggle the file up and down. So, right, there is a way to stand in front of your vise and move this portion back with little as possible wiggle portion back. Okay? And you work on this until it has the shape that you expect. Almost all parts could be produced with a file. It will just take a very, very long time. And of course, working the inside of a part will be very difficult too. Okay? But this is perfect to take off a little bit of an edge, right? Or to reshape your part. If you want to cut screws, you could use this insert. All right. You replace protectors, they have magnets. And you can see that there are some inserts to put screws in here, and then you can tighten it and file down your screw, or after you cut the screw with a saw, to remove the sharp parts that could hurt somebody. So these are the two inserts, the no insert, which is pretty strong, the rubber, and the insert for screws. So this is our disc sander. There's a table here. There's an additional device that can help you adjust angles for sanding, right? And you can also adjust the table itself, opening these two screws and have different angles horizontally. I tighten this again. Right. You will need to connect. If there's only a small amount, you can clean up later. If there's a large amount, you connect the vacuum cleaner here to suck out all the dust. Okay, there's a switch in the back here. Okay, this is coming upward, so probably you don't want to sand on this side, you want to sand on the other side. Right, I can make this 9 degree, tighten, move this in, and pieces off, but really fast. Okay, we want this at an angle. Our piece has an angle. Okay, that is quite handy. Of course, now we have a mess here, and we will need to clean up. But before clean up, we will take a look at the grinder. All these tools, you need to wear safety glasses. Okay? This grinder has two stones, a fine one and the coarse one. The coarse you make faster progress, and with this one you get a finer surface. All right. We have these splash protectors. Turn this on. This is not made for wood. This is made for steel. Okay. If I have this here. Okay. Now I have a nicely rounded or indented side here. And you can also use this to grind off this little knob. It's almost gone. Please be aware that the tool will get hot, so it's usually a good idea to have a glass with water where you can cool it down. Okay? If you need to grind metal, aluminum is a really not good part to grind here. You should use a file, and even a file is not the best thing. What will happen is that the aluminum will get caught in the pores of this grinding stone, and it will get dull. So try to avoid grinding aluminum. I believe these are all the tools I wanted to show you.